Hi, today we are on pages 33 and 34, and we are going to talk about the last type of just kind of weird factoring, which are called perfect square trinomials. So again, the process of factoring is the same, just sometimes weird things could happen like today. Okay, so what we're going to do is we're going to factor these three problems like we know how to do, and then we're just going to kind of see what we notice. Okay, so the first one, okay, we're going to do 1 times 25. So the puzzle is what multiplies to 25 and adds to 10. Okay, well, I know that 5 times 5 multiplies to 25, and it also adds to 10. Okay, so I'm going to break up 10x into 5x and 5x. And then I'm going to do my groups. The biggest factor in this one is an x. The biggest factor in this one is a 5. And when I divide out, I get an x. And when I divide out, I get a 5. Great. For this next one, okay, we're going to do 1 times 9. So the puzzle is what multiplies to 9 and adds to negative 6. So we have 1 and 9 and 3 and 3. So it looks like it would have to be a negative and a negative to multiply to a positive 9, but add to a negative 6. So we're going to split up negative 6x into negative 3 and negative 3. And then we make our groups, and the biggest factor is an x. This first thing is a negative, so I'm going to divide out a negative, and then it looks like a 3. Okay. Then x squared divided by x is x. Negative 3x divided by x is negative 3. All right. This last one does have an a value, so we're going to do 9 times 4, which is 36. And we have to figure out what multiplies to 36 and adds to 12. Okay, so we have 1 and 36. We have 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So it looks like 6 and 6 is what multiplies to 36 and adds to 12. So we have 9x squared plus 6x plus another 6x plus 4. Then when we group them, we have an x. We also have a 3. Okay. Then in here, it looks like we just have a 2. So we have 3x plus 2. And then when we divide 9x squared divided by 3x, we get 3x. And then 6x divided by 3x is 2. All right. What do you notice about the polynomials or the factors of each polynomial? Well, it looks like they are the same each time. Okay. And how do the factors compare to the original problems? Well, if we look back at the original problems, we notice that, 5 times 5 is 25. 5 plus 5 is 10. Same thing for this one. Negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. Okay, so a perfect square trinomial is the result of the square to square a binomial, and we'll have one of the following formats. Write the factors below each trinomial. Okay, so if we have a squared plus 2ab's, just like right here, we had 2 of the same thing, okay, plus b squared. Okay. Looks like we would have a plus b times another a plus b, or we could rewrite this as a plus b quantity squared. Okay. For this one, which is very similar to this problem right here, we simplify and we would get our factor, and we would get a minus b times another a minus b, or we could rewrite that as a minus b quantity squared. So what we're going to do is we're going to go back to the beginning and we're going to rewrite these answers even simpler. So if we ever notice that we get the same answer, we could simplify it as doing x plus 5 quantity squared. This one would be x minus 3 quantity squared, and then this one would be 3x plus 2 quantity squared. Okay, the questions below can help you determine if a polynomial is a perfect square polynomial. Again, guys, if you just feel confident with just factoring and knowing that sometimes you could get the same exact thing, that's how I would do it, but there are always tricks. So is the first and last term perfect squares? Okay, if so, list the square roots. Is the middle term twice the product of the square roots found in step 1? If the answers to both questions 1 and 2 is yes, the square is a perfect trinomial. Okay, sort the letter of each polynomial based on whether it represents a perfect square trinomial. So first, are the first and the last terms perfect squares? So I'm going to take the square root. Square root of 4 is 2. Square root of x squared is x. I'm going to take the square root of this one. Square root of 25 is 5. Okay. I'm also going to just do these all the way down. Okay. The square root of x squared is x. The square root of 81 is 9. The square root of 2x squared, the square root of 2 is not a whole number, so I already know that C doesn't work. Okay. The square root of 16 is 4. The square root of x squared is x. And then the square root of 9 is 3. So just knowing if these are perfect squares, C is not a perfect square trinomial. Step 2, is the middle term twice the products of the square roots in step 1? So if I were to multiply 2x times 5, I would get 10x, okay? And I would have to double that and get 20x. Now, does A work for that? Nope, it does not. So A cannot be that. All right. If I do, for this one, the middle x times 9, which is 9x, and then if I double it, I get 18x. So it looks like that could be a possibility. And then if we do 4x times 3 and get 12x, and then double it, we get 24x. Looks like that is true. So it looks like B is a perfect square trinomial, and so is D. Okay. So knowing that, I could assume that my two answers should be x plus 9 quantity squared for this one. This one should be 4x plus 3 quantity squared. Okay. And these might be able to be factored, but they are not perfect square trinomials like the B and D. Okay, now we're going to put everything together and just factor some awesome problems. Okay, so number 1, is there a GCF that can be factored out? That's always the first thing we ask ourselves. Is the polynomial any of these terms? Because if it's no A value, it's pretty easy. We can just do the puzzle and write our answers. If it has an A value, we will have to do A times C and do the grouping. Okay. The difference of squares, which meant we had two things and we could take the square roots of both of them. And then a perfect square trinomial is what we just talked about, and we will factor it that way. Okay, so first one, x squared plus 26x plus 169. Okay, I look for a GCF. Nope, there's no GCF. Okay, does it look like x squared plus bx plus c? Yes. So what I'm going to do is I am going to figure out what multiplies to 169 and adds to 26. So I'm going to get my calculator out. I need to figure out what multiplies to 169. So 169, and it needs to have a sum of 26. So I'm going to start by dividing by 6. Now that's a decimal. 169 divided by 8, decimal. 169 divided by 9, decimal. 169 divided by 11, decimal. 169 divided by 12. 169 divided by 13 is 13. Okay, so I notice that these are the same thing. Cool, good to know. Let's just keep going. Okay, so then it is does not have an A value, so I should just be able to write my puzzle. Okay, it is the same answer to my puzzle, so it is quantity squared. Okay, what you could have done is you could have went back through and seen, okay, well, the square root of x squared is x. The square root of 169 is 13. X times 13 is 13x. And then if we double it, like right here, we would double it, we would get 26x, which does match my middle term. Okay, again, it's a lot of different tricks to remember. I would just feel confident with just remembering that we're just factoring, and you can always do the AC method. Okay, the next one, 25x squared minus 60x plus 36. So these have some really big numbers. So we're looking for GCFs first. This has a 5, this has a 5, that doesn't have a 5. So because these numbers are pretty big, what I'm going to do is I'm going to look for maybe and see if it's a perfect square trinomial. It's not going to be a difference of squares because it's not two things. So what I'm going to do is I'm going to take the square root of both of these. So the square root of 25 is 5, and the square root of x squared is x. And then the square root of 36 is 6. So then what I'm going to do is I'm going to see if it works by multiplying them together. 5x times 6, which would be 30x, and then doubling it. And it does get 60x. So it seems like this will be a perfect square trinomial. Okay. And if you were like, man, I have no idea what she just did, you could do 25 times 36. So let's do 25 times 36. And I got 900. So the goal is what multiplies to 900, but adds to negative 60. And we would notice that it would be negative 30 and negative 30. They multiply to a positive 900 and they add to a negative 30. These are the same exact thing. Okay, so we could factor by grouping, doing 25x squared minus 30x minus 30x plus 36. I change colors. Then if I do my groups, as you can see, a 5 can be taken out, and so as well as an x. And then I'm going to take out a negative, and it looks like I could probably take out a 6 as well. Okay, 5x minus 6. Okay, then 25x squared divided by 5x would be 5x. Negative 30x divided by 5x would be negative 6. So I notice if I do it by grouping, I also get the same exact thing. Okay, but if you do see the trick at the beginning that these were, it followed the trick of a perfect square trinomial, you could have noticed, okay, well, it has to be 5x minus 6 quantity squared. Right. For the next one, x squared minus 29x plus 100. So first I look for a GCF. It doesn't look like there is a GCF at all. So I have to figure out what multiplies to 100 and adds to negative 29. Okay, so 100 is 1 and 100, 2 and 50, 5 and 20, 25 and 4. Okay, so I think it'll be negative 25 and negative 4. Now again, these have nothing to do with each other, so it's just x minus 4 and x minus 25. Okay, next one, 9x squared minus 42 plus 49. I don't really see a GCF. These are some pretty big numbers, so I'm going to look and see if I can take the square root of them. Square root of 9 is 3. Square root of x squared is x. Square root of 49 is 7. So let's multiply them together. Okay, 3x times 7 is 21x. If I double it, I get 42x, which does match this. So it looks like it should be 3x. It needs to be a negative 7 squared. Okay. Ms. Carter writes the following perfect square trinomial on the board, but the middle term is erased. Declan believes the middle term must be 16x. Is he correct, or is there another possibility? Okay, so what I'm going to do is I'm going to take the square root, get x, and get 8. I'm going to multiply that and double it, and I do get 16x. And so I think that he is correct. and that would be the only time it would create a perfect square trinomial. Okay. Rebecca is making square potholders for our family Christmas presents. The area of the potholder is that problem. So let's go ahead and see if we can figure out the sides. Again, big number, so I'm going to take the square roots and see if that helps. Square root of 144 is 12. Square root of x squared is x. Square root of 16 is 4. I'm going to multiply them together and get 48x. Now I'm going to double it, and I get 96x. So it does look like it is a perfect square. So we have 12x, so positive, so plus 4, quantity squared. Okay. Draw a line to classify each polynomial and align to its factors. Not all factors will be used. Okay. All right, so what I'm going to do is I'm actually going to simplify them because I find that easier. So we get 4x squared plus 10x minus 10x minus 25. So that cancels out, and it looks like this is going to go to that. And we get two answers. They are perfect squares. Okay. 2x plus 5, quantity squared. I'm going to write it out. We get 4x squared. We get 10x. We get another 10x, and we get 25. So we should get 4x squared plus 20x plus 25. And that doesn't look like any of my answers, so that's okay. For this one, it'll be the same thing, but it'll be with subtraction. 2x times 2x, 2 times negative 5, negative 5 times 2, and then negative 5 times negative 5. So we get 4x squared minus 20x plus 25. Okay, so this is a perfect square trinomial, and it was this one. Okay, and then finally, 4x times x is 4x squared, negative 5x, negative 20x plus 25. Looks like it is neither, and it is that one. All right.